Thank you.
Okay, green light.
Maybe I'm good to go right now.
Yeah. To go, you can start.
Okay, thank you. Good afternoon, everybody. I'm Pietro Maggi, and as I said before, I'm here today to talk about building Android UIs for any screen size. But I'm not going to cover Android TV, Wear OS, or Android Auto. So I'm really talking about smartphone, tablets, desktop, and everything in between in these categories. I'm Pietro Maggi, as I said. I'm working as a developer relation engineer at Google, and I have a focus on large screen and foldable support. You may have seen some big announcement last month, or at this point, at Android Developer Summit, including 12L feature drop, upcoming updates for the Play Store to assess large screen app quality and more. It's important to understand that 12L is a feature drop, different from a yearly release that drives the minimum target API requirement for the Play Store. So even if 12L introduces a new API 32, the requirement in the Play Store will be next year on API 31, and the year after that on the next earlier release. That we don't know what number is going to be. We know that is currently known as Android T. So let's move on then. First of all, there is a lot of content available from ADS. If you have not yet already seen it, there is a playlist that I put it here. And during this talk, I will point out sometimes that there is a deep dive on a particular topic on one of these talks. And you may have a sense of deja vu watching the videos because I've stolen a few slides from the different talks to talk about different topics. Okay, in this talk, I will focus on the developer tools and libraries that makes it easier for you to scale your application UI to support a wide range of screen sizes. We will walk you through a collection of APIs and tools which help you make the most of your UI as screen size scale up. And I have a personal sweet spot for Jetpack WindowManager, and I spend some additional time covering this API. But before we jump into all of that, I want to cover why Google is making such a fuss about large screen. And this is really about the opportunity size and the market with a really good growth potential. The last 12 months, we have seen nearly 100 million new tablets activation, and Chrome OS grew by 92%, the fastest growing desktop platform. This means that there are over 250 million large screen devices running Android across tablet, foldables, and Chrome OS devices. And speaking of foldables, we have seen foldable devices on the rise with year-on-year growth of over 250%. Device manufacturers are increasingly recognizing this form factor as a device differentiator opportunity in the premium phone segment. And this 250% growth is without the new Samsung Galaxy Z Fold 3 and the Flip 3 that looks like that are selling really nicely. With the rapid growth of tablets and foldables, it's time to stop thinking about phones and tablets separately. Design and build your application for the ecosystem to increase your app reach in the market. The upcoming month, the Play Store will be introducing new incentive for developers to target large screen, including per device type app ratings. It's now time to get ready for these changes to ensure that great apps ratings across all device types. Doing the work now will also ensure your application avoids awkward user experiences, such as having your application letterboxed on large screen devices because your UI isn't scalable. I invite you to test your application on the Android 12 emulator. If your application is currently setting a resize activity false or a screen orientation portrait, you are going to see that the new compatibility mode in 12L kicks in and will adjust your application in sometimes in unexpected ways for the developers. So it's important to test this on the Android 12 emulator. And we know that there will be some hardware in the future that support Android 12L. We are probably going to have support from a Lenovo tablet, and we are planning to have a support on the Samsung Galaxy Z Fold 3. You can find additional information on user engagement on large screen on the keynote of ADS and see how Spotify is built for Android across different screens. I can only add that Google is pushing very hard on tablets and foldable support. You may have already seen that some of our applications like Google Photos have already improved support for large screen, and we are not going to stop there. We know that this is not a sprint in a marathon, and we are into this for the long run. So I'm talking about a large screen and on Android since at least 2 or 3 years, and this is growing slowly, and we expect this to grow over time, and it's a very nice market and a very nice growth potential for both Android and the whole ecosystem of applications. As I said, I have a personal favorite in today's topic, in today's presentation, and is the Jetpack WindowManager. I want to start on this topic, and we will find references to this library throughout the presentation. And this is not only because I spend a lot of time on this library, but we are going to see that Jetpack WindowManager is a low-level building block that is used by other higher-level components like the sliding pane layout, window size classes, and so on that we are going to see during this presentation. So let's start from Jetpack WindowManager. Jetpack WindowManager is a library that gives you backward-compatible APIs to work with window metrics and size. And this is now in beta. The current release is beta 3, and we are expecting to have another beta release later this month. So it also provides detailed information about display features like folds and hinge and device configuration. So this is really the entry point to start to have better support for a foldable device. Today, I am going to cover the stable APIs available in the library, and we will take a look at some of the new experimental tools in the current and upcoming releases that are going to help your application to look great on large screens. The library takes advantage of the latest feature in 12L, but also works with prior platform version down to API level 14. This means that some features are going to only be available on 12L, but most of the features are going to work down to API level 14. And I will point out which features are only available on 12L and everything else is API level 14. We're currently we have on beta 3, as I said, and we plan to have at least another beta before moving to RC. We hope to have it out this month, but we will need to change one of the API that we have at this moment to address a potential memory leak that we discover at this point. So you should expect a small API change in the next release, but most of what I'm going to talk about today, it's about the stable API. So, and even the change is not going to impact much the code samples that I'm showing today. So let's start with window metrics that is part of Jetpack WindowManager. In the Android 11, we have introduced a new window metrics API in the WindowManager framework API. And this was really to provide a way to measure accurately the current window that your application is running in. At the same time, we deprecated a few APIs that were used in the past to retrieve screen size information. And more APIs have been deprecated in Android 12. And the reason is that some of these APIs, well, these APIs were built for a different time when your application was mostly running full screen. And it was possible that these APIs, these now deprecated API, were returning incorrect values on the latest platform version. So this is why we deprecated this set of APIs, and we have now the WindowMatrix API. On large screen devices, it's very likely that your application won't be occupying the entire screen, since the user engages in split screen and other forms of multi-window much more often. On the Samsung Galaxy Z Fold series, we have seen a 7x increase in split screen usage. Another example is when the window of your application is letterboxed on a large display in a different orientation, because the app compat mode kick in, and maybe your application is not resizable, but is now letterboxed. It's important to make your application fully resizable for this reason. But how can you know the size of your activity? The WindowMatrix API returns the correct pixel size of the window in all the possible state. And Jetpack WindowManager brings this capability to all the way back to SDK level 14. It's also inform you about the maximum possible matrix if the user expands the application on the display so that you can select the right resources to load ahead of time. Remember, WindowMatrix can change at runtime. So the recommended way is to update the values when the activity is first created and when the configuration changes And you can use the WindowMatrix calculator for this from the Jetpack WindowManager. So please don't use any more deprecated display APIs like getRealMatrix or getRealSize, or you may get unexpected size values when your application is running in split view or is letterboxed by the platform. If you need to be notified for all the window size changes, you may want to add a utility view to the container to look into view on configuration change. This is required for all activities, even those that don't handle configuration changes. We also can't use activity on configuration changed, since there are situations where that won't be called when the configuration change. So this is a bit strange, maybe. There are some optimization in the framework. So when the window size changes, in some cases on some platform version, the activity is not notified about this configuration change. So instead, view on configuration change is always called in those scenarios. This is why adding this to the view can be very is the best way at this moment to get this kind of notification. Another key component to making your application intuitive for user on all device form factor is to provide different layouts. We have heard your feedback that knowing which screen size to develop for is difficult in our diverse device ecosystem. Now, Jetpack makes this easier than ever with window size classes. They are being introduced to provide opinionated layout breakpoints for you to know how to adapt your UI. Window size classes will be useful both when selecting the right layouts for different device types and when responding to window size changes in multi-window. Historically, users mostly interact with one application at a time in portrait, but tablets are commonly used in landscape. And with foldable devices and different multi-window modes, it will be more common for applications to go through large and small window sizes in a single session. And it's best to support as many as possible. Look for this new API for the window size classes in Jetpack WindowManager 1.1. That at this moment is not yet released, but we are planning to release it shortly as soon as 1.0 goes to RC. I will also cover this topic later with some additional details regarding the window size classes. So there is a big potential for innovation, as I said, especially for foldable devices. With an increasing number of those on the market, you can go one step forward beyond just making it compatible with large screens and adapt to different device states when users fold or unfold while your application is running. Supporting different modes will bring new ways to interact with your application and new experiences to enjoy. For example, one common posture on foldable device is tabletop, best for watching videos or taking calls hands-free or making selfies with a standing phone. In this case, the device is positioned so that the part of the display is at comfortable viewing angle and part is laying flat on a stable foundation, making it suitable for interactive elements. So button, controls, and so on goes in the flat area, and the viewing is on the side that is comfortably positioned. So let's take a look at the library of which features the Jetpack WindowManager provide you to build this kind of UI. So to determine the posture, you can use a folding feature, a class that enables you to monitor the state of a foldable device. An application can receive events when there is a change in the device hinge and use the occlusion type, orientation, and state to adapt the UI around it if necessary. There are two possible states for the folding feature, flat and half open. For flat, you can consider the surface to be opened entirely flat, even if in some cases it may be still split by a hinge and not fully continuous. Take, for example, a Microsoft Surface Duo. Even if it's flat, you have two screens that with a hinge that separate the two viewing areas. In this case, you may check the occlusion type. And for example, on the Microsoft Surface Duo, the occlusion type is going to be full because part of the hinge is not visible. For a half open position, for the state half open, the windows is always at least presenting two logical areas. So, and this is why you can put the viewing material on the top part and the controls on the bottom of this, on the bottom area. Information about feature layout is provided via a WindowInfo repository. And to start and stop the event collection, we can use a life cycle scope, tracking while activity is visible. So to make it clear, this information is provided with a Kotlin flow. There is also an adapter for callbacks and a couple of adapters for RX Java 2 and RX Java 3. But the default one that is included in the library is this flow. You can then use the information available in the window layout info object to update the layout. Folding feature includes information like hinge orientation and state, and so we can use this information to check if the device is, for example, in tabletop mode. So in this case, if it's, I can check if it's half open and if the orientation is horizontal, the orientation of the hinge, not of the device, and I know that I'm in tabletop mode. So if the orientation is vertical, it's what I can call book mode, where I'm holding my foldable device like a book. To make maintaining this new layout easier in the long run, we also have a new test APIs in Jetpack WindowManager. We introduced a dedicated window testing module in the library for this. Here is an example of creating test instances of the main classes. Notice that activity is the only parameter in the folding feature function without a default value. The current default configuration for a test folding feature is set to be horizontal across the middle of the screen and is half open. Window LayoutInfo publisher rule is a test rule that can be used to override the window LayoutInfo. The window testing rule can be used for testing logic around window LayoutInfo or for testing UI and how it responds to folding features. You should chain the rules together to use window LayoutInfo publisher with an activity scenario rule. In general, you want to have the activity scenario rule to be the last rule in the chain so that the activity started after the dependencies have been set up. Window layout info publisher rule does not replace an end-to-end test on a device. One example is if you rotate the device, a real device will update the corresponding window layout info. But when using the window layout info publisher rule, you must do this manually, overriding, so publishing a new window info layout. The window layout info publisher rule is useful for testing UI and how it responds to folding features. You can chain it together with an activity scenario rule. So the publisher rule does not fully, okay. So this is an example, but this is a full example, and you can see here a sample test from the Jetpack WindowManager sample on GitHub. So we are setting up the feature. In this case, I'm using the activity. It's half open, horizontal, so it's a tabletop. And I'm creating this as the expected window layout info. I'm publishing it, and then I can use Espresso to check that the UI is with the configuration that I'm expecting it to be. So I can set up and push the layout info configuration, use Espresso to check the layout. So we saw that Jetpack WindowManager provides backward compatible access to window metrics information and future-proof support for foldable devices. As I said earlier, we see this library as the foundation to support adaptive UIs and simplify adapting your application to large screen devices. We recognize that converting existing legacy code base to support large screen may be challenging. For some applications that have over time invested into using activities for individual screens, switching to multi-pane layout via fragments or other tools may incur insignificant refactoring and a lot of team resources. In order to make the transition easier, we're introducing activity embedding, a set of WindowManager Jetpack features for modern large screen devices that allow flexible organization of activity windows. We're practically enabling the possibility to have more than one activity on the screen at the same time, defining in your application, you can define the rules, how you want this activity to be put on screen and when. But it's important that this is not just dependent on Jetpack WindowManager. This is a 12L feature that we expect that may be backported to older Android version for some devices, but it has a requirement on the framework. So it's not backward compatible to the API level 14. Like I said before, this is one of the feature that is depends on the latest feature in Android 12L. So for the application where that has problems supporting moving to fragments and using something like the sliding pane layout and so on, you can use this showing two activities on the screen. How this works? You have so first of all, this is an experimental API introduced in Jetpack WindowManager Beta 3 with the goal to minimize the work to adapt your application. And the basic requirement is to add a configuration XML that tells to the library how we want to pair the activities. The key information is the minimum width at which we want to show both activities at the same time. Then we are going to specify the target windows, particularly which one is the primary. And then we are going to reference the activities. So there are more features available in the library at this moment. This is really just the surface. You can use the 12L emulator to test it. We have part of this, and there is already documentation online. We are updating the sample to include this, an example for embedded activity. As I say, this is not the best practice, is a workaround for existing applications that are activity-based. So you can test it today using the 12L emulator, and you will find these features soon on real devices like the Samsung Galaxy Z Fold 3. And when it's not available, if you are using this feature, simply it falls back to the regular presentation. So when you move from one activity to the other, you get them on stack, one on top of the other. So it's fully, you can use it without any problem. And there is also an API to check at runtime if the feature is supported on the device where your application is running, if you want to check on this. As I said, the API has many more features to handle backstack, multiple activities, and placeholder. For example, if you want to have a list view when you want to have a placeholder if no element of the list has been selected, you can do that with the library. So please take a look at the documentation, and we plan to update this. So please test this functionality and provide feedback so we can update the APIs that it is experimental. So this is a very quick overview of the Jetpack WindowManager library, and there are also dedicated modules for accessing window info layout information through callbacks and using RxJava, as I said. And you can learn more about this checking the complete guide on building for foldables in our documentation and on the dedicated sample on GitHub. And there is a dedicated talk about optimizing media application. So you can look for the best practice for video application on foldable and large screen that has been recorded at ADS. They show how to build a fold-aware media player based on constraints layout, motion layout, and Jetpack WindowManager. Okay. Let's talk about the building adaptive UI. So let's break out of the phone and design and develop for responsively now. We have done a lot of work to make this as easy as possible for you across the development cycle. So let's jump right in. So I briefly introduced the window size classes before when I was talking about Jetpack WindowManager. Let's dig in to see what they are and how they are going to be used, and we're going to find them in the guidance, the APIs, and also in the toolings that has been introduced in Android Studio. So window size classes are a set of opinionated viewport breakpoints for you to design, develop, and test resizable application layouts. These breakpoints will help you understand the key size to optimize for you to ensure that your application covers as much as possible of the ecosystem. The window size classes breakpoints have been broken into 3 categories: compact, medium, and expanded. They have been designed specifically to balance layout simplicity with the flexibility to optimize your application for the most unique cases. The recommended usage of these breakpoints is to make high-level application layout decision. They also map to the material layout breakpoints for layout grid columns changes. So the new window size classes coming in Jetpack WindowManager 1.1 will enable you to break away from the error-prone is-stable logic, Boolean logic that has become especially fragile with the introduction of foldables. And let me explain what I mean here with an example. Talking with a lot of developers, helping them to support foldable device, I happen to sometimes applications that have some kind of telemetry to know if they're running on a tablet or on a phone. And you know what, if you are launching one of these applications on a foldable like the Samsung Galaxy Z Fold series, you launch on an external screen, the application is running on the phone. Then you unfold the device, well, the application is running on a tablet. And you go back and forth, tablet, phone, and the telemetry is practically useless at this point. So it's really not anymore a Boolean decision on which kind of device the application is running on. So, and this new API will also negate the need for custom logic around large-scale portrait configuration changes for most cases. We'll just be able to design for the different window size classes breakpoints, and your application will adapt to the right layout in various app states. We also recognize the familiarity with thinking about layout in terms of devices and configuration. To make things easier, each size class breakpoint represents a majority case for typical devices and configuration as seen here. And this can be a helpful frame or reference as you think about the design of your breakpoint-based layout. To be explicit, the compact width represents your typical phone in portrait mode. Medium width represents tablets, and larger foldable inner displays in portrait mode. And the expanded width represent tablets, larger foldable inner displays, and desktop in landscape mode. So we go from compact with the phone, medium, large screen in portrait, and expanded large screen in landscape. In addition to these 3 width-based breakpoints, we are introducing 8 breakpoints with the same category names to provide additional flexibility for more advanced layout scenarios, such as optimizing for landscape form UIs using the compact 8 breakpoint. In most of the cases, you will only need to adapt your application based on the width, but these are available for the most complex UI, or if your application requires this kind of decision. So to summarize, window size classes represent a big step in adaptive and responsive layout development in Android across updated and improved guidance, new API in Jetpack WindowManager, and new tools in Android Studio. Speaking of Android Studio, we have a new category of tools coming to Android Studio Bumblebee called reference devices. Since Android apps should be built to respond to and adapt to all devices and categories, we are introducing reference devices across Android Studio in many tools where you design, develop, and test UI and layout. The 4 reference devices represent phones, large foldable inner displays, tablets, and desktop. These reference devices have been designed after analyzing market data to represent either popular devices or rapidly growing segments. And they are also designed to enable you to ensure your application works across most window size classes combination. If you just take one thing away from this talk, remember this checklist. To make sure your application scales well across devices, optimize your layout for both compact and expanded width size classes. Next, test your application on all reference devices. Every application is different, so pick the layout that works better on medium with size class screen for your application. And to make your app really stand out, consider additional improvements such as custom layout for foldable insert poster or a custom layout for medium width breakpoints or 8 breakpoints. Also, don't forget about how users interact with larger screen devices, often with additional input tools like keyboard, mouse, and stylus. You can find more details about window size classes in our documentation. You will see both window size classes and reference device appear throughout the rest of this presentation. For an example of window size class in action, check out our Jet News Compose sample. The first step to supporting adaptive UI is designing your application in a way that behaves nicely on both a small and a larger screen. This may be quite intimidating, like facing a blank piece of paper. It is important to consider how your application will be used in different contexts and what you want to enable with the additional screen space. We have been working on new material design guidance that will help guide you scale your application UI. We have published guidance on common UI structure prevalent in the ecosystem and will help inspire and kickstart your effort. Leverage these resources to make it easy to get started with layout ideas and enhance the design across phone, tablets, and folding displays. For a demo on how we updated the layout, navigation, logic of Tracker to work on large screen, you can watch the Build Android UIs for any screen size video. So let's start with views. So we're going to see an example on how to adapt an application from a phone to a larger screen. And we can see how we can update an existing application to rapidly optimize for our screen size with the help of the new Jetpack API and other Android Studio feature. We'll use Tracker, an open source sample task management application that we have recently updated to better support larger screen devices. Tracker was developed to showcase accessibility best practices within Android, and with the recent update for large screen, you can use this as a great example for your application. Let's take a look at what we did to make Tracker work great on large screen devices. Before we made any changes, this is how Tracker looked, regardless of device or screen. We had a single pane list of a stack with a bottom application bar for navigating to the archives and or settings screen. As you can see, this initial design didn't make any adjustment for larger screen, and the result is a bit underwhelming. The app works, but it doesn't look good. So let's start analyzing the navigation graph. The application has 5 main views: a list of the tasks, each task details, a screen to create or edit task, and a settings and archives view. The navigation graph, before we have done any large screen optimization, flowed like this, with the list of tasks acting as the home page, enabling navigation to the settings or the archive page. For a demo on how we updated the layout, navigation, and logic of Tracker to work on large screen, you can watch the Build Android UIs for any screen size video. One component that I want to highlight in this talk is the sliding pane layout. This component provides an easy way to support a two-pane layout, and what is great about the sliding pane layout is that it allows me to easily reuse existing layout code. So let's start again considering the updated navigation graph. As a quick refresher, this is the current state of our application. The navigation rail, this is in the previous sample, in the previous step that I jumped over for time, there is a navigation rail now that covers the application. And we want to put together the task list and the detail view. In this case, I can use the sliding pane layout and the navigation graph change in this way, where I have a two-pane task that shows both the list and the detail. And by updating our application this way, we will have the same navigation graph for the application regardless of the screen size. The sliding pane layout, it's using these two fragments, and decide based on the available screen real estate if showing both on screen, so the list and the detail, or just the list or just the detail. Because both task and detail will be presented in the same new fragment in sliding pane layout, this new two-pane task, we will add a new sub-navigation hierarchy specifically for the navigation interaction for this fragment. This will make sure that when I select a task, and then my app goes from the two panes to one pane, that item will be on top of my navigation stack and will be visible. This could happen if I was folding my foldable, for example. So moving from the internal screen with both list and detail to the external screen with just one of the two fragments, and to decide which one, it's important to have this information to know which one is on the top of my navigation stack. So again, because of time, I'm going to jump a bit over here. The full explanation of this sample, the code is on GitHub, and the Build Android UIs for any screen size covers this topic in detail. Next is Jetpack Compose. So Jetpack Compose, in addition to making it easy to update your existing application with adaptive UI best practice in mind, we are excited to introduce Jetpack Compose as one of the key tools in your pocket to make it easy to build large screen and diverse UI layouts. If you're starting to adopt Compose, this is a great time to also consider optimizing for large screens along the way. Compose reached version 1.0 this June, and since then we have seen tremendous reaction from the Android developer community. Tens of thousands of applications are already using Compose in production, including the Play Store itself. Compose is a declarative UI toolkit for who doesn't know yet this, meaning that you can describe how your UI should look based on the state, and you let Compose figure out any updates needed. All UI is described in code, and it is easy to make decisions at runtime for how your UI should look. Notice this is a big difference with the view system, where we rely on the resource qualifier to describe different screen configuration at compile time. This makes Compose especially great for developing adaptive UI, as it is very easy to handle UI changes across different screen sizes. no matter how many improvements we make to the existing Vue toolkit, it will never be as easy to adopt these sort of changes as it is with Compose. So in the last few months, we are updating our JetNews sample to really shine on large screen. So let me show you some of the steps that we have taken and how Compose make it easy. And I want to focus on a small part. So first of all, JetNews has a main screen with a long scrolling list of articles. And before any optimization for large screen, this is what the app looks like when scaled to a large screen. This is not a good use of additional screen real estate, as you can see. There was a lot of room for improvement. So the point that I want to showcase today is how the window size, adopting the window size classes in Compose UI made it easier to start to support a larger screen. So we have covered window size classes concept earlier. At the moment, we are working on a Compose integration. So it's not ready yet. Even the window size classes are not yet released. They are released because they are coming in version 1.1 of Jetpack WindowManager. But we are working on this idea to have the two things working together. In the meantime, we have created this composable function that handles the integration with Jetpack WindowManager window metrics API that we have seen before. So using the window metrics calculator and the breakpoints defined by the window size classes guideline. So we can reach out for window metrics of the current baking activity and remember them correctly as compose state. Then translate those to DP size available to the application. And once we have the available size, we can easily translate it into a window size class, compact, medium, or expanded, as we saw before. The window manager library will soon expose API for these classes directly, and Compose will have API to handle this directly. But in the meanwhile, you can borrow this code, this integration code from JetNews. As a note to the window metrics calculator that we are using in this composable, as we saw earlier, this is an API included in Jetpack WindowManager and replaces a whole set of APIs that are now deprecated to retrieve the window size classes, the window size. So I know I'm repeating myself, but this is a very important point. When you need to retrieve information on the window size, use window metrics. Use the window metrics calculator from Jetpack WindowManager, use the window metrics from the framework that are available in Android in the API level 30, yes, Android 11. But don't use the displays API like real screen size and so on. So for a demo on how we updated the layout, navigation, and logic of JetNews to work on large screen, you can watch the Build Android UIs for any large screen size video. The source code is on GitHub. There are articles covering this, and we are working also on other samples, converting the other compose samples, and in some cases adding also support for foldable postures like tabletop and so on that we saw before. So Jetcaster is currently updated to handle postures. So change the UI depending if it's flat or half open in tabletop mode. So let's now talk about testing. That it's always at the end of the presentation, but it's probably sometimes more important than everything else. So we have shown how to easily update your application or build new UI to be resizable. Let's talk about testing and maintenance of this code. We know that maintaining UI across all form factors can introduce test complexity. And we are adding new testing and automation tools and APIs to allow you to scale and testing across more device profiles without significantly increasing the burden of doing so. It's difficult to own physical devices representative of all the screen sizes and form factor. We sought out to provide a quick, seamless approach to run existing instrumentation tests on a variety of screen sizes and API levels through virtual devices. With Gradle Manage Devices, you can simply describe the configuration of devices you want to run your test on, and Gradle takes care of the rest, including device provisioning and test execution to create a consistent, reproducible testing environment. Simply define devices in your build script and add them to a device group, such as a group of devices with medium and expanded with size classes. Then use the group of Gradle Managed Device to run your test. Because Gradle managed both of the device provisioning and test execution, Gradle Managed Device also support test sharding, which allows you to split your test across a specific number of identical devices, reducing your overall test execution time. Simply pass this flag to specify the number of identical instances of each device you want to shard your test across, and Gradle takes care of the rest. But we know that running a large number of virtual devices can be taxing on your CPU and memory and potentially limiting the usefulness of Gradle Managed Devices in test sharding. To help, Gradle Managed Devices introduce a new type of virtual device that is optimized for instrumentation tests called automated test devices. This device runs in a headless mode with disabled background processes and services that you typically don't need for automated testing, reducing your overall CPU and memory usage per device. This will allow you to run tests targeting multiple devices, representing different screen sizes simultaneously. Currently, ATD are available for Android 10. Higher APIs level will be supported over time. And to make sure that your existing screenshot tests continue to work with automated test devices, we are updating the Android X testing library with screenshot APIs that dynamically update the Android X testing library, that dynamically toggle hardware rendering only when they when required to capture a screenshot, ensuring that automated test devices run as efficiently as possible. While this is a lot of great functionality for how you run your test, we're also thinking about how to help write better tests, and particularly testing your application through configuration and device state changes in a synchronous way. And this has always been very challenging. It becomes even more important now to write this for large screen and foldables, especially for foldables where you have configuration changes. Even just using the device is not just anymore the rotation of the screen, is really also the folding and unfolding. So working to have a good app continuity in your application is very important, and being able to test for this, it's critical. To help, we are working on a brand new set of Android X testing API that allows you to put the device in different state or postures. So in postures, it means folding postures, so in tabletop mode, book mode, flat device, and so on. For example, you can test how your application reacts when the device goes from being folded flat to half open, or is rotated between portrait or landscape mode, all with synchronization built in. And this is the critical point. You could right now do ADB commands in your test, but it's never synchronized. So, and this is what is going to be the best improvement with this. We're still gearing up a preview release of this API to first work with virtual devices, so look out for announcements soon. So we have covered a lot of ground today, starting from Jetpack WindowManager, then the new design guidelines and window size classes to specify APIs for updating existing applications with such sliding pane layout, new UI in Compose, how to integrate with window size classes, and overall testing tools to help you scale your UI to larger screen sizes. Larger screen and foldable represents such a large and growing segment of Android. And to take advantage of this momentum, now is the time to build and design UI responsibly. So users on most premium devices have a great experience and are going to be happy using your application and provide great reviews for your application. So we are excited to see how our application can evolve and what else we can do to help you seize this opportunity. So we are also eager to get feedback on this new feature. So please reach out to us. The whole team is head on the ground to listen how the community is adapting this feature and the reaction of this new feature that we presented. So there is a lot of new features coming out across material design, 12L, the Play Store and Jetpack to help you in your large screen journey. And we have only covered a few today. So check out the newly released large screen guide where you will find everything we covered today and more. And this is the new entry point for adaptive UI, large screen foldables. So we are planning to keep this up to date, release new documentation over time, launching updates to the library there and so on. So we spent a lot of time to remove all the honeycomb image from the documentation, and we are planning to do even more of this. So this is just the start of the journey, and we know that we take time, but we are determined to provide you with everything needed to easily support small and large screen devices across Android surfaces. So thank you for your attention, and ping me for any question on large screen and foldable devices.